So, this is how you do the vector notation representation, guys. Hello.
Are you studying for the upcoming test?
Yes.
Can you just explain to me because I think it's forgetting something. First, let's talk about scalar quantities. A scalar has magnitude only, means it tells us how much but not the direction. Scalar quantities are always one dimension, and any change in a scalar only affects its size or values. When we add or multiply scalar together, the result will still be a scalar. However, if a scalar is multiplied by a vector, for example, when a scale across by 2, the result became a vector. Example of scalar quantities are speed, time, mass, temperature, and energy. Oh, so that's for scalar. What about vector? So vector is a vector quantity is both magnitude and direction. When we perform operation with vectors, the result can be either. So a scalar such as when we calculate a dot product or another vector such as when we subtract or sum their cross product. Example of vector quantity is include displacement, velocity, acceleration, torque, and momentum. Can you give me an example so I can understand more?
So I can give you an example. So if you take a look here. For this vector example, I will be explain using a simple map between three places at Polytechnic Unku Omar. Point A is the Department of Mechanical Engineering, Point B is the Department of Marine Engineering, and Point C is the Perak Jubilee Hall. The first step is to representing as vectors. From the map, the distance from B to A is 100 meters at an angle of 45 degrees from the horizontal. That means when we move from B to A, we are moving partly to the right and partly upward. To represent that as a vector, we're using trigonometry. The movement in the x direction is 100 cos 45 degrees. To calculate the movement in the y direction is 100 sine 45 degrees. Because both cosine and sine of 45 degrees are 0.7071, we get that x is equal to 70.7 meters and y is equal to 70.7 meters. The vector for A to B is 70.7, 70.7. Step 2 is to find vector BC. From the map, B to C is a straight horizontal line, so it only has x direction movement of 120 meters. That gives BC is equal to 120 and 0, since there's no vertical movement. Step 3 is to finding vector AC. To go directly from A to C, we add both vectors, which is vector AC is equal to AB, vector AB plus vector BC. It's best to say that if you want to find vector AC, we need to substitute the values. So we do it by 70.7 plus with 120 and 70.7 plus with 0. So we get the vector for AC, which is 190.7, 70.7. Step 4, we need to find magnitude of AC. To find the total distance from A to C, we use Pythagoras theorem, which is vector AC is equal to the square root of x squared plus y squared. So, as to put it simply, we substitute vector AC square root of 190.7 square plus 70.7 square, and we get the total of 203.4 meters. So in conclusion, we can say the distance from vector AC is 203.4 meters. This shows how we can use simple vector methods to represent direction and distance between points on a map, like places around Polytechnic Unku Omar.
Now I understand it again. Thank you for explaining it to me. Can we do more exercises now?
Sure.